Hello everyone, in this video I'm going to discuss the topic differentiation. A. By writing the tangent equals to sine over cos. Show that differentiate the tangent x respect to x is equals to secant square x. Show that differentiate the tangent x with respect to x is equals to secant square x. Hence, find the differentiation of the tangent bracket cos 2x respect to x. So first, differentiate tangent x, where tangent x is equals to sine x over cos x. Let us represent it as u and this one as v. By using the quotient rule, we have v, which is cos x. Then differentiate sine x, we will have cos x minus u, where u will be sine x. Differentiate the v, which is cos x, and we will have negative sine x over v squared, where we have cos x bracket square. Expand the situation, so we have cos square x plus with sine square x over cos square x. As we all know, based on the basic identity in the trigonometry, cos square x plus sine square x, which is equals to 1. So finally, we have 1 over cos square x. Based on the trigo ratio, 1 over cos square x is equals to secant square x. So finally, differentiate the tangent x respect to x is equals to secant square x. The situation has been shown. Next, the question asks us to differentiate the tangent bracket cos 2x. So, how to differentiate the situation? Differentiate tangent bracket cos 2x. So by differentiate the tangent, we will have secant square bracket cos 2x, followed by differentiate the cos 2x. Differentiate the cos, we will have negative sine 2x. Next, what we're going to do is to differentiate the 2x, and we will have 2. So finally, differentiate tangent cos 2x respect to x will be equals to negative 2 sine 2x bracket secant square bracket cos 2x. If sine bracket 2xy equals to x plus cos bracket x y squared, evaluate the dy dx when y is equals to 0. So first, my suggestion would be identify the value of 0 before we start our discussion. So if y will be equals to 0, we will have sine 0 equals to x plus cos 0. So as we all know, if sine 0, we will obtain the value 0. For cos 0, it will be equals to 1. So x will be equals to negative 1. So meaning that when y is equals to 0, x will be equals to negative 1. So now let us start our discussion, which is finding the first derivative. So if we differentiate the sine bracket 2xy, so we will have cos bracket 2xy. Next, we are going to differentiate the internal function, which is 2xy. So 2x will become u and y will become v. So we will have y bracket 2 plus 2x differentiate y, we will have dy and dx. Equals to differentiate x, we will have 1. Differentiate cos, we will have negative sine xy squared. Let the u as a x and v for the y squared. So bracket, we have y squared bracket 1 plus x, differentiate y squared, we will have 2y dy and dx. So by substituting the value, y is equals to 0 and x equals to negative 1. So we will have cos 0 multiply with 2 bracket with 0 plus 2 multiply with negative 1, and then we have y prime equals to 1 minus sine bracket 0 multiply with 0 plus 0. So for this case, the whole thing will become 0. For this one, we will have 1 multiply with 0. So we will have negative 2y prime equals to 1. So from here, we notice that we will have negative 2y prime equals to 1. So the first derivative, or we said the dy dx, will be equals to negative 1 over 2. So here we are, and thanks for watching.